Arctic News. Saturday, March 18, 2023. Sea surface temperature at record high. As the above image shows, the daily sea surface temperature between 60 degrees south and 60 degrees north reached 21 degrees Celsius on March 16, 2023, the highest temperature in the NOAA record that started in 1981. This record high sea surface temperature comes as we're moving into an El Nino, as illustrated by the image on the right, adapted from NOAA. Moving from the bottom of a La Nina to the peak of a strong El Nino could make a difference of more than half a degree Celsius, as illustrated by the image below, adapted from NOAA. Even more dangerous are sea surface temperatures in the North Atlantic, which have been at record high for the time of year for some time, as illustrated by the image below. Around this time of year, North Atlantic sea surface temperatures are at their annual low, in line with changes in the seasons. Last year, North Atlantic sea surface temperatures reached a record high of 24.9 degrees Celsius in early September. On March 15, 2023, sea surface temperatures off the east coast of North America were as much as 13.8 degrees Celsius or 24.8 degrees Fahrenheit higher than 1981 to 2011, as illustrated by the above image. Anomalies are also high in the Pacific, reflecting an upcoming El Nino. This spells bad news for Arctic sea ice, which typically reaches its lowest extent in September. The above Argo float compilation image illustrates the danger that a cold freshwater lid is forming on top of the North Atlantic. Cold freshwater lid on North Atlantic, 2020. Stronger winds along the path of the Gulf Stream can at times speed up sea currents that travel underneath this cold freshwater lid over the North Atlantic. As a result, huge amounts of warm, salty water can travel from the Atlantic Ocean toward the Arctic Ocean, abruptly pushing up temperatures and salinity levels at the bottom of the Arctic Ocean. The above Argo float image illustrates the danger that heat can reach the seafloor. North of Norway, where the water is less than 400 m deep, temperatures higher than 5 degrees Celsius show up throughout the vertical water column over a period from May 31, 2022 to March 16, 2023. The panel on the left of the above image, from an earlier post, shows sea surface temperatures on June 20, 2020, while the panel on the right shows a bathymetry map indicating that the sea in a large part of the Arctic Ocean is very shallow. The above map shows the thickness of Northern Hemisphere permafrost on land and below the seabed. The above image describes how methane can escape from the permafrost and the seafloor of the Arctic Ocean. The danger of destabilization of methane hydrates is especially large where methane is present in submarine permafrost and seas are shallow, such as the East Siberian Arctic Shelf, ESAS, see image below. The above image was created with content from a paper by Natalia Shakova et al. From an earlier post. As illustrated by above compilation image, both the volume and extent of Arctic sea ice are low for the time of year. The danger is that, with further melting of sea ice and thawing of permafrost, the Arctic Ocean will receive more heat from direct sunlight, more heat from rivers, more heat from heat waves and more ocean heat from the Atlantic Ocean and the Pacific Ocean, resulting in destabilization of methane hydrates at the seafloor of the Arctic Ocean leading to explosive eruptions of methane, as its volume increases 160 to 180-fold when leaving the hydrates.